actions. System actions, object context manipulation actions, and variable manipulation actions. So there are a set of actions that we have in functions that will help you to perform your perform the task that you would like to do. So there are certain system related actions like alter, execute, create, menu, display. Object context related manipulation of actions like new object, insert collection object. Then we have a variable manipulation actions like set, exchange, increment, decrement. So these are some certain listed actions. I mean, these are the frequently used actions in functions. Then user interface actions like the start progress, show progress, end progress, message box, query box. Debugging actions like log, set log on, set log off, set file log on, set file log off, log object, log target, and file input output actions. So what are the system actions? All the system actions are available within TDL functions for usage. The system actions are primarily meant for the purpose of opening a report in the specified modes. So we have the action keyword and its parameters. Action keyword can be any actions, global actions like menu, display, create, call. In that case can also be a system action that you can call another function within the existing function. Depending what is your action keyword, the action parameter can be menu, report, or a function name. Then we have object context manipulation actions like the new object. This creates a new object from the object specification and sets it as its target. New object, object type. The type of object it is, say ledger or group or voucher, stock item. The object identifier, it's an optional parameter, and there is a forced create tag. Object identifier is optional for cases where it is in create mode. Obviously when you are creating an object you do not know the identifier. However, in the cases where it is an alteration mode or an edit mode is where an object identifier is expected. So object type is the type of the object to be created. Object identifier is the unique identifier of the object. If it is existing in Tally in the database, then the further manipulations can be performed on that object. Forced create flag is optional and is required only if the object identifier is specified. If the flag is set to true, then if the object identified by the object identifier exists, the object is altered. Otherwise, a new empty object of the specific type is created. So if the group by name, e-group name exists, then it is altered. If it is not existing, it is forcefully created. Insert collection object. This allows us to insert a new object in the specified type of collection and makes it its target object then. This is specifically required when we talk about the sub collections that we have in a particular object. For example, if we have the current object as ledger and our current context is ledger and we are pushing values, we can have an insert collection object address to push the details of addresses to this ledger. Well, but this insert collection object address only moves the focus from the current primary object to the sub collection or the sub object address. Then we have an action called set value. This action helps us to push value to the method. So we have set value colon the method name colon the formula, the value that you want to push. Reset value resets the value of a method for the target object. The method value formula is evaluated with respect to the current object context. If value formula is not specified, then it sets the existing value to null, basically empty. See, set value basically has to provide a value formula, and that is how it sets the values. In reset value, if you provide the value formula, then it changes according to that. If you don't provide it, it makes it null. Then target object manipulation actions. We have 3 actions: create target, save target, or alter target. Create target accepts the target object to the company database, creates a new object in the database if it does not exist, else it shows an error that it's a duplicate, that it already exists. Alter target accepts the target object to the company for alteration. So if the object does not exist, it results in error. So what happens in cases where create target is mentioned but the object exists, it's an error. In case alter target is mentioned and the object does not exist in the database, then it results in error. However, save target or accepts the target object to the company Tally database. If another object exists with the same identifier, then the object is altered, else a new object is created. So if you are very specific on not letting people to alter the object but to provide a message that the object exists, you can use create target. Where you would not like people to create a new object but just to alter the existing one, you can use alter target. Wherever you would like it to perform, if available then alter, if not then create, then you make use of a save target. When you make use of a save target, please ensure when you provide a new object, you do provide an yes flag for the first create flag. Then we have an action called set object. Sets the specified object as the current object context. So this is one example we have mentioned. Object colon object ledger. So my current object context is ledger. So when we write $name, it returns me the ledger name. Set object colon bill allocations first, return and $name returns me the first bill name from the bill allocation. And when specified set object dot, so one dot is for the current, so my current is bill allocation. The second dot is to the parent, so it goes to my ledger object. And now when we mention $name, again this $name returns the ledger name. Then we have set target, sets the specified object as the target object in the context. Then variable manipulation actions, we have sets a value to the variable, exchanges or basically switches the values of two variables with each other, increases the value, increases the value of the variable by 1 if the counter is not specified, and if the counter is specified, then that is what it takes as an increment counter. Decrement decreases the value of the variable by 1 if the counter is not specified. User interface actions. When a function takes some time to execute, a progress bar can be shown. At times we don't know what is happening, and the user simply tries to terminate the application by switching to end task and say end program or end application, and tries to kill the application when it is actually trying to perform some actions. We can show progress bar to the customer, which will help the user to understand whether there is an action being performed or not. So start progress allows to mention the total number of steps involved, title to it, subtitle to it, and subject of the progress bar can be given as parameters. So the number of steps is the total quantified number, 10,000, 20,000, that's the total number of steps, and a title is mandatory. Optionally, you can provide a subtitle and a subject to this progress bar. Show progress as to show the current status of the task of the user. So show progress : the number of steps completed. So now you can show the number of percentage it is completed. And then we have the end progress. Please note, this obviously makes me understand that it has to be for the looping constructs, because that's when we generally have the progresses happening. 1. The start progress should be outside your loop construct. So basically it's before the loop construct starts, and end progress will be after the loop construct is over, and show progress has to be between the statements of your looping constructs. I do not mean between means you do divide by 2 and say okay, this is the 5th line here, but it should be within the loop construct. So your start progress and end progress with your loop construct will be between the start progress and the end progress, and your show progress will be within the loop construct. So that's how your progresses will be checked on. Query box. This action is used to display a confirmation box to the user where the message expression gray back flag and escape as yes. So when you give a message, you can give a message. That's a query box. You can say yes or no. So when you have a message and you say gray back flag, that means same as in the message box. It's a gray back. And escape, so when you press, by default an enter is yes and an escape is no, but in case you want to make escape as yes, by default enter will become no. In general scenarios, when you press enter it is yes, and when you escape it is no. However, in scenarios where you want to make escape as yes and enter as no, the last flag has to set to yes. Message box is only to show the message that your task is completed or task is completed. That's a message box. So you can provide a message box. It requires a title, a message expression, and the gray black flag, yes or no. Now we have a very critical user interface action called start batch post and end batch post. Basically, a performance lag has been observed while we are updating a user-defined function as compared to the updating the data of a similar size by import methods of an XML. So when you start importing XML, you see it goes very fast. But when you do it with a user-defined function, the entire work first has to get flushed into the function, and then the function has to push it out. So there is a lag, there is a performance lag between the data getting flushed from the XML to the function and to the database. Hence, importing of data implicitly follows a batch posting approach. Most of you might be aware about the synchronization procedure that Tally follows, where we have also provided an option where we say, do you want to continue synchronization with which batches? This is where it comes into picture, where you can say, okay, import at 100 at a time. So that's so at one given point of time, it does not flush the entire XML, but it flushes 100 of XML together. So it goes into batches of 100. This gives a uniform experience to the user, and the performance automatically improves because it now goes into small package that the application can well manage. So rather than flushing everything together and making application helpless and overloading the application, the batch post will help the application to manage this entire work, and definitely gives a better experience to the user with a better improvement. So the batch post, so the action is start batch post and end batch post. You start things in between this. New object is the action, and you can perform whatever actions you want within this posting, where you can provide the batch size. Batch size is the size of each batch, that at one given point of time it can take only say 10 object in one batch. So this will definitely improve the performance. Operation on batch posting action. The actions batch post and end post are procedural actions which can be defined only within the user defined functions. This indicates that all the data updation action falls between this. So whenever you are trying to import something and create new objects, all the actions for this should be between the start batch post and end batch post. So this will update the database in batches. Instead of bringing the entire chunk together, the data and then updating into a temporary file and then push the data, flush the data. So instead of data being directly updated into the database, which will obviously log the database for some time, the data is first updated into a temporary file, and once the batch size limit is reached, the entire data is flushed from the temporary file to the database. So it behaves like a router. First, the data is pulled from the main source to a temporary file. It reaches its limit of 10, holds there, and then pushes the data to the database. On encountering the batch size limit, the temporary file flushes the data into the Tally database. Only on the completion of the previous batch, the subsequent batch posting iteration takes place, and this will continue till we complete the entire loop of pushing the data, for calling the data and pushing it into the main file. This is one of the example where we are trying to create the number of ledgers. So you're trying to create 1000, start post for 100. So in first post only 100 will be generated, flushed, and then the next 500 will be generated and flushed. So this is the explanation of the example that we have. When the function create ledgers is invoked, it has 1000 ledgers to create, ranging from customer 1 to customer 1000. If batch post was not used, the database files would have got locked and released for updating every object. So first one is trying to generate, it locks the database, pushes, unlocks, again locks, second is created, unlocked, third is created, locked, unlocked. So this entire cycle contains 1000. So this locking of database will happen 1000 times. So the other users which are using the same database will experience the performance getting affected, because the database gets locked and released multiple times, and at given point of time the report is opening, report takes time. So this will happen when customers face this experience, because the database will get locked for the cycle of 1000. When batch post is used, what will happen is first 500 object will be collected and pushed to the database in one shot. So when that 500 is getting pushed, the database will be locked for that one particular time and released. After that, for the next 500, it will lock it for the second time, push the data, and it will release. So when there is a large data volume that has to get flushed, it will take lesser time to push more data. So you need to remember, start batch post and end batch post are used in nested manner. Only the first instance is considered, while the rest, if you even mention it, it is ignored. If the user misses the closing part of the batch, the system will end the batch implicitly. So even if by any mistake a developer forgets to write end batch, the system will end the batch as per its needs. This does not mean that it gives you the liberty of not writing end batch post, but please ensure you do that. This is in the cases where you actually forget to write it. One must take the backup of the data prior to the batch posting feature, as incorrect usage may lead to data corruption. Use of parameter import batch size is to improve the performance while importing of data. Now we spoke about the message box, right? Now we have something called as asynchronous message box action. These asynchronous message boxes are the boxes that continues to appear till the action end message box is encountered for the function or the function is terminated. So when you give a message box, that message box will come only once. But when we talk about asynchronous message box, this message box will continue to flash till end message box is encountered or the function is terminated. It is called asynchronous because this action is executed n number of times, that it is not expecting a user to press any key, but it will continuously flash the message box and continues to execute the subsequent action. So message box is continuously flashing, but see, generally when it's a message box, it is expected that the user should press escape, right? But in this case, it is not expecting the user to press the escape key. It continues to flash message box and continues to execute the rest set of actions. So this is how it goes: start message box, title, message expression, the list of actions you want, and end message. So this, you can show that this function is creating some ledgers. You can start your progress, and so that nobody disturbs the process. Although the progress bar is going on, you can continuously show the message that the function has created 10 ledgers, and you can keep flashing that on your screen that there are ledgers that are being created. Until the end message is not received, it will continue to do this job. So let me show you one example of this. Please note this feature was added in release 4.8. So below this release, this particular feature would not work. And we go with this. So this is to display the operations between the started and performed to create 300 ledgers in the current company. So additional 300 ledgers will be created in the current company. Click on enter. You see this message box on the right hand side. This will be appear till the action is encountered. So you see that it's not I am pressing an escape key, but that is not going to work. Right now I'm showing the progress bar. It will continue to show this message box till my creation of ledger is not completed. Very simple. You see this quit because we had pressed escape. Now we can go to accounts info, ledgers, alter, and you will see we have so many ledgers created. We would have around 300 ledgers created, right? It's starting from ledger 0. That's the reason why it has ended at 299. So you saw that on the right hand side, the message box was continuously displaying till the ledgers were created. That's the functionality of asynchronous message box. We call it asynchronous message box, but you can call it as start message box and end message box. So in any case, say you are trying to perform some actions and you leave your desk, the user leaves the desk and just starts wandering around, and somebody is trying to do something. You can simply this continuous messages can say, please wait, there's something happening, do not try to interrupt it. That's what can be done. Then we have the debugging actions. Please note this is nothing, this particular actions has nothing to do with the user, it has to do with the developers. So please ensure that you turn off the debugging actions the moment you are delivering your project to your customer. Please ensure that is done. During the expression evaluation, and the intermediate values of the expression can be logged. This is helpful for the debugging of the expression. So you want to know when something is happening and you want to log what is the current status. Could be anything, say calculation, or the current object type, or probably the current string value that you have received in your variable. Whatever it is you want to log. So this expression needs to be passed to the calculator window. The debugging actions are set log on and set log off. Log on is to start the log and log off is to off the log. This will log the values in your calculator pane at the bottom. At the right hand, you see there's a calculator panel at your bottom. Tally screen. This This is what is used for set log on. So when you say set log on, whatever you ask for logging will be shown here. And when you have set file log on and set file log off, when you say file log on, the values will be logged in TDL func.log. And when you say set file log off, it will stop recording the log in your set file log, the file TDL func.log. Log object allows logging the current object context details in a file. Current object context corresponding methods and sub-collections are logged. So what will happen is, when you talk about log, it will allow you to do some expressions and details. Well, a log object will allow you to log details of your current object context that you are into a file. So what will happen is, you can provide the file path and you can ask whether you would like to override the existing file. Now the file path is optional. It accepts the name of a file with the path in the log that you have to create. If no file name is specified, then the contents will be logged into the TDL func.log or calculator window. So if you write set log on, it will go to calculator window. If you say set file log on and you don't provide the file name, it goes to TDL func.log, and if you provide the file name, it goes to the specific file. Override flag is used to specify whether the content should be appended or overwritten. Whether the file the next time you write the object gets logged, should it get added or should it just override the existing file. So if you do not mention, by default the value is no, that means it will start appending, and that's what we generally follow even in cases of synchronization logs. So this is an example. Then we have log target. So when you write log object, it is the current object, and when you write log target, it refers to the targeted object. So this log object and target object, one will help you to check what values are coming from the source. Two, log or target will help you to see the values that are getting pushed to your target. So pretty helpful for the debugging action, specifically when you are playing around a lot with your objects. And now we come up to the very important part of the TDL procedure capabilities, input-output capabilities, which we also call it as file I/O capability. TDL procedural capabilities. A typical high-level programming language supports read from a file or write to a file, which can reside in your hard drive or a network. Now with the new capabilities of TDL, it is possible to export almost every piece of information in any data format we can think of. We support text and Excel, which allows data storage in SDA fixed with or SCV comma separated, sufficing the generic data analysis requirement of any business. Now there are various TDL artifacts for reading and writing operations. Hence, new actions and functions are introduced to ensure that these work, and this will work only within the procedural block. Write operations are mostly handled using actions, while all file access and read operations are performed using functions. The major advantages, these constructs gives tremendous control in the hands of the programmer for performing manipulation of the data, and file can be accessed via FTP or HTTP for read-write operations. So might not necessarily a file be physically present on your hard drive, but can be read from an HTTP or an FTP also. The source file we have as for data, we have two data contexts, the source object and the targeted object. Similarly, for files also we have two contexts, source file context and target file context. Source file context, when a file is open for reading purpose, the context available for all read operations is the source file. All the subsequent read operations are performed on the source file. When a file is opened for writing purpose, the assumption is that it is the target file in which you will be writing some data back. So when you open something in read, by default it is source. Something that you open in write mode, by default it is target. The file contexts are available only inside the procedural block, so where the files are open for use. File contexts are available for the functions and subsequent functions that are called within the function. The call function can override the inherited context by opening a new file within its block. So I have a function which has opened file 1 in a read mode. Then they can call a function within the function which will open the same file in a write mode. So now for the function 2, the file 1 is now the target file, but for function 1 it is still a source form. Both the file contexts, source and target files, are available simultaneously. This makes it possible to read from a file and write to another file together. So you can have two files, one for the source and one for the target, and you can read and write simultaneously. The operations that can be performed on the file is one, obviously you need to open the file, and this file can be in read mode or write mode. An open file can be closed. This is an operation which closes the file after the operation read or write is completed. Read, this is an operation just to read the data from an open file. So you can open the file, you can read from the file, and you can close the file. So read will be used on your source file. Then we have the write operation. This will write data back to the file. Seek is an operation to move the character position in an already open file. So this would be the seek will be working in your text files. Truncate is an operation which will delete the particular number of characters or the entire content of the file. So you can, truncate can be used as your log file. So the next time you start reopen a file which already exists, you can empty the contents so that the new log can be generated for it. So the kind of overwriting, when we spoke about overwrite log yes or no, when you say overwrite yes, it just truncates the contents and starts a fresh log. That's what truncate helps us to do. So you can create your own truncate file for your log. So the general operations that we will have, the source context is used to read the context from a file which is open for reading purpose. Target is the file in which we will write the data, which has to be open, and both the files, read and write files, can be open together. Open file, file name, file format, open mode and encoding. Please note, see, all the parameters are optional. File name can be an expression which evaluates to a regular disk file. File format can be of a text or Excel. When you do not mention the file format, by default it is considered to be a text file. During opening a file, while opening an existing file, if the mode does not match, the action will fail. The open mode can be a read or a write. If you don't mention the mode, it will be a read file. If a file is open for read purpose, then it must exist. If it is for write mode, it must be specified. If the file exists, it will open the existing file for updating. If the file does not exist while you are writing it, it will create a new file. So if the file is open in the write mode, it is also possible to read from that file. Encoding, this can be an ASCII or a Unicode. If not specified, it will be considered as Unicode as default value for write mode. In read mode, this parameter is anyways ignored because the encoding format will be considered from your read format. Open file, file path, file type, and the open mode. And the next one, you can see open file, file path with the name, with the format, with the operation and the encoding format. So only while writing back, encoding will be read. While reading, the encoding would not be read. The encoding format specified will be ignored. Then close file. This action is used to close an open source file. So close, when you write, it is just to close the existing source file. To close a target file, it is close target file. So if you don't have a separate action, what will happen is when you say close file, both the files will be closed. So to close a source file, it is close file. To close a target file, it is close target file. Then a function. All file accessing functions for both text and Excel file operates on source and target context. The function TGT file can be used to switch target file context temporarily, similar to what we have for $TGT object. This function evaluates the expression passed in the context of targeted file. So this is an example where we are trying to open an Excel sheet in a write mode, adding a sheet 1, writing to the cell, first row, first column, item 1, setting a variable value TGT read file cell 11 and add it to sheet 2. So this will just change my targets. File size. This function will return the size of the file specified in the bytes. This function takes optional parameters if the parameter is not given. Then it works on the current content file and returns the size. So whichever the current context file, if you do not provide the file name, it will evaluate on this based on the current file that is open, and if you mention it will return the file size of that specified file name. Well, this could be used to check the bytes of a particular file when it is available. You can check whether the file is updated. If it is 0 byte, then you don't have to perform function. If it is more than 0 bytes, then you can perform functions. So that can be validated. Now the read, so we have bifurcated this onto two operations: read-write operations on the text files and read-write operations on the Excel files. And the previous ones that you saw were the generic for both of them. So writing to text file, various actions are introduced. These actions operate only on the targeted files because it is to write. The scope of this action is only within the procedural block. So when I say write file, this action is used to append a file with the text specified and will always start from the end of the file. Wherever the last cursor is on the file is where it will start from. So I say write file, text to write, and it will write it to my text file. Write file line, similar to the write file, but the difference will be it will start writing but from the next line. So if, for example, say we have this notepad, and this is our text and my cursor ends here. When we give a write file, it will continue to write from here. But when we provide write file line, it breaks the line here and it continues on the next line. So that's the difference between write file and write file line. Again, this action will work only in the context of target file. So write file and you can provide the details. Truncate file. This action removes the content of the file by setting the file pointer to the beginning of the file and inserting an end of the file maker. This can be used to erase all the characters from the existing line before you start writing the new content. Generally, that's what we use when we have to when we generate logs. We just truncate the previous log and we can create a just refresh the contents and start a fresh update to the file. So you say truncate file, you give the file name and then you can write it. Seek file. This action is used to move the file pointer to a location as specified by the number of characters. All the subsequent writes will be starting from this position. By default, the position is if the file position is not specified, the read pointer will always be from the beginning of the file and the write pointer will be at the end of the file. So if you want to write something back at a particular location in your text file, you can say seek file and you can give the position number based on the number of characters. Now talking about the reading from the text file, again some functions and actions are introduced to read. The actions will be within the function scope, and it is also possible to read from the target file just by specifying $TGT file. So there is a function which we have $file read. This function is used to read data from the text file. If number of characters are mentioned in this function, it will read that many number of characters. This takes an optional parameter, and if you don't specify any value to this optional parameter, then it will read one line and ignore the end of the character. However, the file pointer is positioned after the end of the line character, so the next read operation will start from the next line. So that's how it will work. So read file, and you can provide the number of characters it has to read. File is end of file. So this function checks whether when you are reading it, the function is used to check if the current character is being read is end of file. Although with your although we cannot see there is a character called end of file, but in all the text files where you have terminated, stop typing, the last character after that is end of file. So this can be a good point to validate that if it is end of file, you don't have to continue to read my text file further. Or if it is end of file, just start back, just go back to the beginning position of my file and start reading it again. That's how it can be used. Action seek source file. This action sets the current file pointer to the position specified. The 0 indicates the beginning of the file and -1 indicates the end of the file. So you, if you do not want to mention any number of characters, how to go to the beginning of the file or the end of the file, this is how it will provide. 0 indicates the beginning of the file and -1 indicates the end of the file. The positioning of the file is determined by the terms of the characters. All the subsequent reads begin from the position, from this position onwards. So seek source file position can be an expression which evaluates to a number of characters. So you can write open file name, the file format, and the operation seek source file :2. It will just go to that particular position. Now read-write operations on Excel files. Again, various actions and functions are introduced. These actions can be operated for writing to the file. When it's talking about writing, it is the target file, and these actions will be within the function. Action add sheet. This action is actually adding a sheet in the current workbook. So an Excel sheet is a workbook. When you talk about an Excel file, it's a workbook having multiple sheets. You can add a new sheet to it, or you may just use the existing sheet that is available. In case you want to add a new sheet, you can make use of the action add sheet for starting a fresh, starting to write freshly on a new sheet. So you have to provide the sheet name. Then remove sheet. If you want to remove the existing sheet, a sheet that is already existing from the current workbook, you can use this action remove sheet : and you need to provide the sheet name. Then rename sheet. You can just provide the old sheet name and you can provide the new sheet name. It requires two parameters. One is old sheet name and then the new sheet name. Then write cell. For text, it will start from the characters, but when we go to the Excel, it is the rows and the columns that has to be written. So when we talk about writing to a cell, you need to provide the row number and the column number. Although when we see the Excel, it is row are numbered and columns are alphabet, but internally they are also numbered. So row number 1, 2, 3, 4 and column number 1, 2, 3, 4. So rows goes vertical and column goes horizontal. So an intersection of row and column makes a cell. So when you write row 2 column 4, the cell A1 A B C D 2 will get intersected. So that's where row number and column number comes into picture. But this is what we have to give that row number and column number. Both you have to provide number 1, 1. Then this is an example of this. So you can see right cell, first row, first column, Krishna. So this is what will be written to your Excel sheet in the sheet, new sheet. Right row, where you know the row number but the column number is not specific, means the column number can increase, is where this comes into picture. When you want to read from the file which has multiple rows and copy the data, you know the column, you may know the row number but you do not know the column number. So this is where it will come into picture. We can provide a static row number and you will have to provide an initial column number. Hence you can provide an initial column number separated, and you can provide values separated by comma. So you can write right row number, initial column number, and two values are there. So it will be written in row 1 column 1 and row 1 column 2. When you write right column, you need to provide the initial row number and the column number will be static. So it will go as row 1 column 1, row 2 column 1, row 3 column number 1, and comma separated values, so the values will go vertical. Now when reading from the Excel, obviously again it's an Excel, it's a cells that you need to read. So we first of all, there would be multiple sheets. So first of all you need to set a sheet active. So the action to set a sheet active is set sheet active, set active sheet, and you provide the sheet name. Then read from the cell. So when you read from the cell, it's the row number and the column number you need to specify. Get a sheet count, that from in the current workbook how many sheets are available, you can count that. Get active sheet name, what is the current sheet name that is active. Get sheet name, and you provide an index number, will return that particular sheet name. So you can first have the count, say I have around 10 sheets, so you say return the count 10, and then you can keep logging how many, get the sheet name 1, file get sheet name :1, then say file get sheet name :2, and then you can check which sheet you need, and then as per that you can make a particular sheet active. Then say for example you know the sheet name and you want to return the index number of the sheet. You have a sheet name called ledgers, which is the 4th sheet. You want to know which sheet number it is, so you can write file get sheet IDX. For name you can write file get sheet name. For index number you can get file get sheet IDX. Then you have get column name. This function gives the column name in the terms of alphabet for the given index. Basically we only know that the Excel has the column alphabets. So basically when you give the index number, it will return that particular alphabet. So when you write 4, it will return D. So that's how this particular function will do. Then you say get file column index. So you provide alphabet and it returns the index number. So you say it is alphabet F. The index number will return 6. So you provide F, returns 6. That's the column index number. So let me just show you one example on this file IO capabilities that we have. So we'll see some Good. We'll see a very practical example that we have. So we can create a report. Let me show you the output in Tally. What's new and release 2.0. Procedural file IO capabilities. Import of stock items. So before we do this, we will have to copy the base files to our C drive. So we go to our sample folders, supporting files. We need two files from here, both text files. There is a file IO data folder. There are two files here. So we'll copy this folder to C drive. Yeah, the files are copied to C drive in the folder file IO data. Right. So first I will show you with the Excel file IO data. The file name is list of stock items. Just read this, list of stock items. It's a .xls file. Name of the sheet is stock item. Stock items. Does this have an header? So we have 3 headers, so we say yes. This will conclude whether the initial row has to be 1 or initial row has to be 2. Then we have columns for each, A, B and C. So column A, column B and column C. So column A, column B and column C. So these are the name of the items and these are the name of the stock groups. Then display error report if any and open log file if any. So we set it to yes, and import stock items. We are importing these stock items and you can notice this item 1, 2 and 3 already exist. So it hasn't been able to create. Group 1 does not exist, so item 4 could not be created. Group 1 again, because it did not exist, item 5 hasn't been created. Item 6 hasn't been created because unit liters does not exist, and item 7 because boxes hasn't been created. So we'll just create one group 1 and liters. So we go to inventory info, stock group, create group 1, and we will create a unit of measures, liters, LTRS. And you will just try this import once again. And here you will notice now, you see items already exist, item already exists. Item 4 has been imported successfully. Item 5 has been imported successfully. 6, 7 and 8 has some problems which has been notified here. So let me show you this code. Here, well, the entire work is on the function, so report designing isn't, you can go through the report design, it's a regular report designing. So we just go to the function. Starting with the first base, whether the files, the query box, yes or no. Here we start with import stock items, yes or no. So on the form acceptance, it checks, it asks you the question, do you want to import these stock items, yes or no, at the end here. When you press enter, it says import stock item, yes or no. The moment you click on yes, it checks for the last result. If it is yes, it checks for the source. If you have given Excel, it will go to this. If you have selected text, it will read this. So the open file path will look for the folder path, the file name and the file extension. That's a file concatenation. So that's how our open file works. Read from the Excel is what it is doing. And then it is setting the initial item columns. So set, this is a work of the list variable, item columns dot item name, and setting the column index numbers. This index number is what we are getting from this initial screen here. So if I say column A, that means it returns column index 1, column index 2, and this is column index 3. And because we have given a header row yes, by default the initial row number becomes 1. So if this is my source of Excel, set the variable row. If this is yes, then 2, else my initial row will be 1. So this is how we have read the file. Now we have given a while loop which checks if to check whether the whether the row or the column that we have is empty or not. That's what we will be checking on. So based on the row number, read from my cell the row number and the item column. Check whether the value is empty or not for this value. Till it is not empty, making use of the list variable, we are reading from this particular column. So the initial row is 2, column is 1 and item name. Then for the group it is 2. So automatically this becomes 2, read the group name, and this becomes 3 and reads the group name and increments the row. So now row becomes 2, column becomes 1, and this is how this loop continues till it finds an empty cell. This will get ended here, and this below part is for the notepad, and we are closing the file. If the log has to be maintained, open a notepad file, provide the details in the notepad file, and then we are giving our details that you work on this collection, that is my source collection of variable, and start pushing the value, start creating the objects. Stock item name, group. So what we are doing here is we have started logging the values here. Set last status to group. So our last status is our variable, notice here, and this is a definition created for last status here. So last status, we are appending a value here when it is at the group level. Stock group does not exist. If not, check for the units, say stock unit does not exist. If everything is okay, if last status is empty, save the last status as imported successfully. And if the item is already created, give the last status as item already created. And we are appending the values into our last status. Then here we are providing the log details to our text file. Stock item name concatenating with this text and the last status. We are writing it to the file. Apart from that, in our import status variable, it's a list variable, we are adding the counter as a key, item name, the name of the item and the last status, and then we are closing our walk. So what happens is all this is getting added to the list variable, and finally what we are doing is we are simply flushing all the values from this import status list variable to display the report value. So if you look at this, this is our variable, data source variable import status. Filter if it is not empty. And this is how we are doing it. Similarly, for text, the file name, obviously the sheet name does not exist here, so it will be, even if you mention, it will be ignored. Includes header, yes. Stock item is the first one, under group is the second one, and the unit of measure is the third value, separated by a comma. So item 10 and 11 imported successfully, but item 12 did not succeed because of its grouping error. So let me just show you the notepad. Here, name 1, 2, so that's the header we have. So item 10, yeah, item 10, group 1, and our unit of measures, separated by commas. So do we have a header here? Yes, we do have a header here. So what we have done in this code is, let me just go back to the top of the code. And the function here we have seen with the Excel sheet. Now we'll see with the text file. If it is Excel, you have to do this. If it is not Excel, this is what we have done for the text file. Set var read from the file. You have to set the counter to 1. If # temp var is not empty and there is no header or there is nothing, then the loop index and the loop index is greater than 1, start adding values to my list var. This is the list variable with the counter number and the member variable name. We have written a function. This function is for using for token. So for token var ## whatever my value is, and my separator is a comma. If counter is equal to this index number, return the token var and keep incrementing my counter. So this is how it returns the value here. There are 3 parameters: temp var, item column, names. So these are the input parameters, and this is how it is retrieving the value back to my text file. So now this makes the work simpler to import files from our text and Excel. Right? Simple. Thank you, and hope you would have understood the creation of user-defined functions. All the required samples are available in Tally Developer TDL samples folder. Even the supported files are made available. For further queries, do contact our support desk at support.tallydeveloper@tallysolutions.com.